Assalamualaikum and hi. First thing first, let me introduce myself first. My name is MOHAMAD SHAFIQ bin MOHAMAD SHAFIE with MATRIC number 286885. I'm from Group C from subject Introduction to Mathematical Economics by Madam Nurizita binti Jamil. So yeah, what are we going to learn in this video? First, we will learn how to find the concavity using first and second derivatives. 2. We will learn how to find marginal cost function. Third, we will learn how to find the maximum profit and its levels of production. So let's take a look to the question and answers. So for question 1a, determine where the function fx equal to x cubed minus 6x squared plus 18x minus 15 is concave upward and where it is concave downward, 6 more. So yeah, here's the answer. Already given the function fx equal to x cubed minus 6x squared plus 18x minus 15, the first step, we must differentiate the function using power rule to get the first derivative of the function. So we will get 3x squared minus 12x plus 18. Then we must differentiate once again to get the second derivative of function using the same method, which is using power rule. So we will get the second derivative of f function equal to 6x minus 12. So to get the value of x, we must let the second derivative function equal to 0. So the second derivative function of f equal to 6x minus 12 equal to 0. Then we factorized it to get the value of x. So the value of x equal to 2. Then the intervals that we will get, negative infinity to 2 and 2 to infinity. Alright, step 3, test the intervals to identify the concavity. We must draw the table like this. So the first row we do have interval, second row we do have test point, third row we do have value of the second derivative function and sign, and lastly concavity. Alright, for the first intervals, which is negative infinity to 2, we just put negative 1. So we substitute negative 1 into the second derivative function of f. So the value that we will get, negative 18. And of course, the sign is negative. So this means the second derivative function less than 0. So for the second interval, which is 2 to infinity, we assume to use 3 as a test point. Then we substitute into the second derivative of function f. So the value that we will get is 6. And obviously, it is positive. Then the concavity that we can conclude that in here, the second derivative function of x more than 0. So, like you can see, the second derivative function less than 0, which concave downward, maximum point, and second derivative function of fx more than 0, which concave upward, minimum point. So, the conclusion, the function of fx equal to x cubed minus 6x squared plus 18x minus 15 is concave downward on the interval negative infinity to 2, and is concave upward on the interval 2 to infinity. So let's move to the question 1b. Suppose that the cost function for the manufacturer is given by Cx equal to 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000. Describe the behavior of marginal cost function. So we do have 1 Roman and 2 Roman. So let's take a look at the first Roman. So question 1b, 1 Roman. Find the marginal cost function. So already given the cost function, which is 0.00001 x cubed minus 0.003 x squared plus 5x plus 1000. So to get the marginal cost equal to dc over dx, which means equals to the first derivative of the cost function. So we must differentiate it using power rule, then we will get 0.000003 x squared minus 0.006 x plus 5. Next, we move to the second Roman. So describe the behavior of the marginal cost function, whether concave upward or concave downward. Prove your answer. 4 marks. So we already get the first derivative function. Next, we must find the second derivative function, which is we must differentiate the function using power rule. So we will get the second derivative of cost function equal to 0.000006 x minus 0.006. So to find the value of x, we must let the second derivative of cost function equal to 0. So the value of x that we will get is 1000. So the interval is negative infinity to 1000 and 1000 to infinity. Like previously, we must draw the table. So for the interval negative infinity 1000, so we try to put 500 as a test point, then we substitute into the function, then we will get negative 3 over 1000. And obviously, the sign is negative. So the second interval 1000 to infinity, so we try to put and test using test point 2000, and then we will get the value 3 over 500, and the sign is positive. So yeah, second derivative of cost function less than 0, which concave downward, which is maximum point, and the second derivative coefficient more than 0, which concave upward, which is minimum point. So what I can conclude in here, the function of Cx equal to 0.000001 x cubed minus 0.003 x squared plus 5x plus 1000 is concave downward on the interval negative infinity to 1000, and it is concave upward on the interval 1000 to infinity. So let's take a look on the last question, which is question 1c. A company has established that the revenue function in Ringgit Malaysia is revenue function Rx equal to 2x cubed plus 40x squared plus 8x, and the cost function in Ringgit Malaysia is Cx equals to 3x cubed plus 19x squared plus 80x minus 800. So for the first question, which is question 1c, 1 Roman, find the level of production that will yield a maximum profit for the company, 6 marks. So already given the R function and C function, which is revenue function and cost function. The first step, we must find the profit function. So the formula for profit function is equal to revenue function minus cost function. Then we will get the profit function, which is equal to negative x cubed plus 21x squared minus 72x plus 800. So step 2, we must find the first derivative of profit function by differentiate the function px using power rule. Then we will get the first derivative function of profit equal to negative 3x squared plus 42x minus 72. So step 3, to find the level of production, which is a maximum profit, we must let this first derivative of profit function equal to 0. So negative 3x squared plus 42x minus 72 equal to 0. Then we factorize it to find the value of x. Then we will get x equal to 2 and x equal to 12. So next step, we must differentiate the function of first derivative to second derivative. So using the same method, which is differentiate the function using power rule. So we will get the second derivative of profit function equal to negative 6x plus 42. So using the value that we got from the first derivative function, which is x equal to 2 and x equal to 12, then we substitute that value into the second derivative profit function. So for the value of x equal to 2, we will get 30, which is second derivative of px function more than 0, which is concave upward. And for x equal to 12, we substitute into the second derivative function, we will get negative 30, which is concave downward maximum point. Okay, so what I can conclude in here, since second derivative function of profit less than 0, the level of production that will maximize a profit is when x equal to 12. Okay, let's move to the very last question, which is question 1c, 2 Roman. Find the price per unit to maximize the profit, 2 marks. So already given the profit function, which is equals to negative x cubed plus 21x squared minus 72x plus 800. So we use the value that we already got, which is 12, then we substitute it into the profit function, then we will get 1232. But it's not the final answer. To get the final answer, we must divide it 1232 by 12 to get the price per unit. Then the final answer is Ringgit Malaysia 102.67 cents. So I think that's all from me. Thank you, hope you enjoyed it and gained some knowledge with me.